Hi, Park-kun. So I have your paper just in front of me. Thank you for sending it. So we have your site description here where you present Unzen. We have the north on this one, it's okay. It would be nice maybe to have the Sea of Japan here or Ariake Sea here as well. It's too small for Ariake Sea, but as you were saying the other day, maybe Kyushu Island here on that one would be good. And then we zoom on this, saying that maybe Unzen volcano is in C in that location. So in your figure here, we can have A, B, and in B, you can say that in the zoom you have where Mount Unzen. Okay, that's good. Mount Unzen, perfect then. And then you have your data, methodology, data, blah, blah, blah. Okay, the thing is like, I don't see the objective anywhere. So that might be the place where you want to start. So let's look at your data first, your debris result. So you have debris flow occurrence events. So it's the debris flow events occurrence. Occurrence means like how many times it happens. So events, and here you can put a comma, occurrence. So if you can hear the television, I'm watching guys playing games on YouTube, so that's normal. Okay, so if you start with the results, debris flow occurrence data, that's what we have here. And then we go to that one. I'll say let's see what you've said. So from 2000 to before the monitoring period, I know what you mean, but you cannot say to before the monitoring period because it's any time before that, so it can be any years. So you want to say to the start of the monitoring period. And here you want to say when, because you're not saying when is the start of the monitoring period. Is it 2016, 17? So what I will do is I do use the review thing. So you can watch them, see all track and show markup. All market. And here, say what year here. So from 2000 to the start of the monitoring period, and you can have in brackets 2016, for instance, like this. 11 debris flows have, so it's not that they had occurred and it has changed. So when you use that had here, it means that it's different now. It's not the case. It's have debris flows have occurred, and that's it. And it's not going to change in the future. Figure 2. During this period, the hour area amounts. Blah, blah, blah. Okay, so here you don't need during this period. The hour maximum rainfall intensity necessary to trigger debris flow the hour maximum what is the 1 hour maximum rainfall intensities? There is a problem here. That's not good actually. It's the hourly rainfall. So I'll put a note here. This is not very clear. Like, what do you mean by the maximum hourly rainfall? So within 1 hour, you have multiple measurement and you take the highest one. No, it's like the hourly rainfall intensity necessary to trigger debris flow was recorded in 2004 with 35 millimeter. And you say here that it's intensity, so not 35 millimeters, but 35 millimeters per hour, right? In 2004. And the highest the highest intensity associated with a debris flow has been, or was 121 millimeter per hour in 2015. So the hour, if I go back here, the hourly rainfall intensity necessary to trigger debris flow was recorded in 2004 with 35 millimeter per hour. So here we don't need 2004 anymore. And the highest intensity associated with the debris flow was the highest rainfall intensity, the highest hourly rainfall intensity, blah, 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 blah. Okay. All debris flow events, except for debris flow in 2014, were observed in sediment deposit nearby. Wow. So what do you mean by that? So I'm going to put a note here. I don't know what you mean here. For the period 2016 to 2020, a total of 3 debris flow and 64 surface runoff were detected. Figure 3. Okay, so okay, I think I get no way. Why 2014 here? Like, do you mean that it's everything until 2016? Or yeah, I don't get it. Sorry. So for this part here, now for the period in 2016-2020, a total of 3 debris flows and 34 surface runoff were detected. So here your title is about debris flow occurrence. Why do we have data on the surface runoff? So we don't care maybe about the surface runoff. So and one way you can put this sentence, maybe if you want to keep this way, is to say that for the period 2016 to 2020, it was good actually as it was. It was okay. Out of 64 surface recorded, 64 recorded surface runoff events in the gully, a total of 3 were debris flows. And then we go to figure 3. Okay. So blah, 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 blah. For the period, with the first one here, this is methods, so maybe not here. Maybe that goes to the methods. It's not the place to say what you recorded with what instrument. That should all go to the method. The debris flow that occurred in 2016 reached the check dam past the gullies. Okay, so the check dam is not past the gullies. So what you mean here is pass, but it's not past the gullies because it's still in the gully. Do we have a map of the gully, by the way? Okay, so maybe you can say that you are downstream or overshoot the Sabodam downstream of transect G17 or T19, right? So that's maybe the way to write it. Okay, so from 2000, the problem here is that you are building this text from your methodology. So you have divided your data based on how you recorded them. And I'm not quite sure it's the best way to tell the story. So from 2000, that's a good start. All debris flow event, blah, blah, blah. And for the period 16 out of 603 when it flow. And this we can get rid of. Figure 3. With for the period blah, 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 out of the 3 debris with only the 2016 event that run downstream the check dam at the lower end of the study reach. The other debris flows, and then we use your sentence here. The other debris flows in 2017 and 2018 stopped within the gully, which is perfect. Maybe that you can say that based on the debris flow monitoring. No, you can't say that here. Maybe we can say that for most years between 2004 and 2018, as well as 2016 and 2018, debris flow occurrence concurred with the highest hourly rainfall intensity, with the events, the rainy event showing the highest hourly rainfall intensity. However, from 2019, in 2019 and 2020, debris flows did not occur even after several rainy events, 60 millimeter per hour. Okay, the rainfall threshold that triggered debris flow, blah, 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 blah. This is not your result. This is discussion. So this is discussion. Because you have only a few data sets and it's not enough to say that the threshold has changed. Because look at 2020, you also have above 50, 60 millimeter per hour and nothing happened. In that period also, there is nothing. Here in 2009, we have maybe like 30, 40, but it's not being triggered. So it's quite irregular. Okay, so that's a good way to start with your figure. Figure 2, I will write it this way, 1 hour, 1 hour. You don't start a sentence usually with a number. You want to start with a word of that number. I don't know how to say that. And then we go to a very different element here. So you're saying that we have changed, blah, 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 blah. Okay, I get it. I know why you're putting this here, because this is a transition. So what you can put here is that besides the rainfall variable, beside the rainfall bar variable, topography and blah, 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 blah. No. So maybe we can put it here. Rainfall alone cannot explain the full spectrum of the reflow triggering, and it is because it also depends on the topography and the sediment availability. The volume of sediment in the gullies, it was not decreased, has decreased. If you say was decreased, it means that someone did it. Has decreased until 2016. From where? From 2000? From 2000 to oh, we have it, sorry. We are in 2003, right? Sorry. From 2003 to 2006, before reaching a stability plateau. Okay, so it's not the volume of sediment that you are showing here, it's the accumulated volume of sediment reduction. So it's the rate of change that we have, the yearly, so blah, blah, blah. The volume of sediment in the gullies, the volume of sediment, the rate of sediment, because that's the rate basically, isn't it? 3. Okay, there is a problem. It's accumulated volume of sediment reduction. So it's how much accumulated volume. Here you have to change your title. There's a problem. It's okay. You need to modify the title on axis Y. It's not the accumulated volume of sediment reduction. It's the accumulated volume of sediment eroded. It's a volume reduction, but a volume of sediment reduction. I know what you mean here, but it's not, it's hard to say. And if it's a reduction and you put -50, -100, -150, a reduction in minus means a plus. So you either get rid of the reduction, so it's accumulated of If I were you, I would modify. Okay, maybe you can keep Y, but you should get rid of the minus in front of this numbers, because the reduction in minus equal plus. Okay, so it is the reduction, and so we can go back here, and that was good. So the reduction, the eroded volume, the yearly eroded volume of sediment in the gullies has decreased from 2003 to 2016. Here it would be good to say how much you're losing a year, because here this is the cumulated value. Can you change that graph and have the cumulated value and the yearly value? So maybe you can have it at the bottom, and you can have bars maybe every year, like bar on what we have lost, and that cumulated graph here. If I was you, like a cumulated graph, I would do it the other way around to show the amount of volume which is being eroded. So you can have eroded volume, and this can be positive. The way it's presented here is really, really counterintuitive. So maybe you can change this figure for eroded volume, positive, and you can add a y-axis and also have the yearly data, so that we get on the same graph XX millimeter per year, and we can also see the accumulated value. Okay, so blah 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 blah. So maybe there is a bit of work to do on that figure. Although both the Tansandani and Gokurakudani gullies had a similar trend in volume of sediment reduction in the gullies. Although both the Tansandani gully are you separating those in other places? And is Tsunetaka-san writing it in 2 words like this? Maybe you want to, I know I write it in 1 word. Try to make, to be consistent with the other publication. And Gokura, although both the Tansandani and Gokura show similar trends, unless we don't need blah, 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 blah. The amount of volume means nothing. It's the volume is the same. The volume of exported sediments has increased at a higher pace in the Tansandani gully compared to the Gokurakudani gully. And figure 4. Since beginning in 2011. Beginning, I get it wrong, in 2011. In the Tansandani gully, the volume of sediment decreased what? In the Tansandani gully, the volume of sediment the highest that's for 1 year. So maybe you can have that like this. Oh, no. I don't know. What do you think? In the Tansandani, the highest sediment in the Tansandani, the highest sediment volume we don't need, actually. We know it's a volume here, so it's fine. The highest sediment the highest decrease, and we know it's sediment, has been 78 blah 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 per year during the period 2000 and so you cannot say the highest because it means the top, so you cannot have 2. The 2 highest, let's say, the 2 highest decrease have been 78 blah 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 and blah 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 blah. Okay, you cannot use you can, but it's not good to use on the other hand when you don't have first on the one hand. So usually when you say something like on one hand something, but on the other hand, so you cannot start with the on the other hand if you don't have on the one hand. So that's the Gokurakudani. Yeah, usually it's like when you do an opposition, so it's not a good use here. On the other hand, it's not something that you can really compare. There are two different elements. It's not this way. In the Kukurakudani Gully, the volume of sediment was okay. So you see that structure sentence is the same than earlier. Try to change that following a similar pattern of what I wrote above. There is a problem here of the volume of sediment was highest. This is not good. Maybe here, by contrast, maybe we can say that the second peak of sediment decrease in the Tansan-Dani Gully was not observed in the Gokurakudani Gully during 2015, 2016. And we don't need maybe the number here if it's small. Okay, so here, in spite of two debris flows in 2017 and 2018, so figure 2, great. It did not result in I know that dramatically changed. It's something I use as well, but it's not good actually, because dramatically means nothing scientifically. It's very like subjective. So maybe not using dramatically in an increase in the yearly sediment, easily loss of sediment in the gully. And maybe this here can go off. So try to change this, and then we go to this. Okay, so we go from now the volume to the cross section, which is good. So you can say that the yearly trends can be explained at the cross section scale. The cross sectional geometries of the Tansan-Dani and Gogra at extended caused by due to erosion processes. Indeed. Okay, that's not good, because when you say that it's erosion is you cannot say that or write that, because it means that after 2016 erosion processes do not occur anymore, which is not the case. What you want to say is that there is less erosion. So Unique extending and trends of this change is different. Oh, okay. No, sorry. My bad. I didn't get what you wanted to say. So the yearly trends can be explained. The yearly trends in sediment volume loss and yield can be explained at a cross-sectional scale as well. The cross-section, the geometry, the transversal, not transversal, it's called the geometry of the cross sections. And here it's figure 1, maybe. So we don't have to say of the Townsend Valley, blah, 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 of the two gullies. Of the two gullies. What are they doing? They are widening, deepening, da, 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 da. So let's look at those. So I guess they are deepening and widening. The geometry of the cross-section fires it's not the geometry which is deepening, it's the cross-section. So we can get rid of the geometry. The cross-sections of the two gullies are deepening deep and widening. And we don't know if it's erosion or anything. Well, we know it's erosion, but can we put it? Yeah, there is nothing else. So the cross section of the two gullies are deepening and widening. Maybe we could put it here. Due to the erosion. No. The cross sections of the two gullies are deepening and widening until 2016. Due to the erosion. The oval trend these processes are not similar in amplitude, nor do they occur at the same period, depending on the cross-section location. Okay, no, maybe not for instance. So here maybe not for instance, you can describe what we have. You can say that you have transect 1xxx, which is widening between this period and this period, transect whatever, which is deepening. Maybe give a bit of a short description here instead of this saying for instance. For instance is not that great when you describe result. why do you choose? Because you make a choice on what result you're trying to explain, and what about the rest then? So maybe you can work on that. Sure, you can maybe work on that all part, but do not use for instance to explain your results. It's very slow. Maybe I should save the document before it goes. Okay. Up. The gully was changed, blah, 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 blah. Is there that? And from 2016, the rate of changes decreased overall. And if you have the data here, you can add the maximum and the minimum change, or some information on the change rate. Okay, that's coming next. Some, oh, is it? Blah, 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 def change. Yeah, okay, it's coming next, so maybe not here. The gully width change. The change in gully width continued until 2018. But for both the Tansandani and the Gokurakudani gullies, the geometry stabilized. Furthermore, the depth changes of both geometry decrease range change over time. Okay, this I don't understand. I don't know what you want to say here. Here in the negative value of gully depth change indicates that decrease due to the sediment deposition. So you mean that from 2018, you have aggradation. So you can get rid of that sentence here. And from 2018, aggradation is being observed in the gullies. And here we can say sediment aggradation. So this is the whole area. So it's both and the depth and the width So what you want to do is to put that first, because this is the general. So overall, the geometry becomes bigger. So you can bring that right towards the top. So that goes at the start. So that's the geometry change, the surface, overall surface change, cross areas change. And then once you have your cross area change, you can say, well, there are two ways those can change. They can change horizontally, so it's widening, and vertically. And that's when you explain your vertical and horizontal movement. And instead of having, for instance, here, when you have said that they are widening and deepening, blah, 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 then you can say that cross-section XXXX are widening between this period and this period and this period and this period. And those cross-section, blah, 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 are also deepening between this and this. And then comes the next step, which is say, well, after 2018, actually, then we start to have another a reverse process, which is aggradation. We don't have erosion anymore, and the bed is rising. And that's what brings us right here. What is the ESI? Oh, that's the thing by Tsunetaka-san, right? So you see the general problem you have in this section here is that, again, instead of telling a story and using your data to explain that story or to present that story, we have a division, which is a methodological division of the. It's not a big problem, but we get lost in what you're saying. You're repeating the same things with indicator A, indicator B, indicator C, and it's not the way you want to say it. You want to have a message, which is cross-sectional change, and you show it, then you show how it changed. But you don't go again and again on all the different parameters. Those figures are very nice. The only thing you see, it's very small here. So the numbers on your years here are okay. We can read them. Make sure that those numbers here are also of the same size, so we can also have a look at it. So between cross-sectional topographic change, what do you mean? That's, I have no idea. Do you mean in between in time, in between in space? But if it's in space, how do you get the data? So the platform area change had the largest. So largest here is a superlative adjective. So it has to work with a noun. So that and a noun, but there is no noun here, so it doesn't really work either. But I know what you mean. It's like the highest platform change, the most important, the most extensive, platform area change occurred in the period of 2003, 2005. And is it 2005? Yeah. And the two gullies had a decreasing trend over time. Decreasing trend of what? And the most extensive plateau, and then the change rates decreased for the two gullies, and the change rates decreased over time for the two gullies. So yeah, it does decrease over time, but it's not what we mean. It means progressively until 2000 whatever 20. And for the two gullies, it's maybe not necessary. The most extensive planform area we don't need actually. Change occurred during the period of 2000-2005, and then the change rates decrease progressively in both gullies. Although they display similar trends, the range of the magnitude of planform change significantly differed between the two. Indicating that Tansandani Gully had more lateral eroded, had eroded at more lateral erosion than the Kukurakadani. Experience, maybe, yeah, I don't know. The channel gradients of the Tansandani. Okay, so here we have planform, and then we have the. Okay, that's what you mean. So you see, the problem is that you start with the gullies as a whole, and then you divide them into cross section, and then you go back. But those are different again. So we need to change the title here. So what about you say planform and gradient change? 4.3.3 to planform and gradient change and slope gully and vertical change. Planform vertical change of nope. So that has to come first. That has to come here. We have the general blah, blah, blah. And then we don't know if it's debris flow here. We have the change. So it's not the change of topographic factors, it's the topographic evolution of the gullies. So the volume change, and the volume change is linked to the topographic evolution of the gully. So that needs to go next, actually. So that has to be 4.2. 4.2.2. So the topography change, and then you zoom on the cross section, and you explain how the topography change, and then you have 4.3, which is with the volume, because we calculate the volume from the topography and from the topographic change. So you cannot start with that, it has to come afterwards. So let me go back to your result. So you see you have your result that starts saying that we have debris flow, the debris flow, we have less debris flow, and the triggering factor range from that much to that much. But in recent years, we have actually high rainfall, but we don't have debris flows. And then you're saying, well, that's when you hear you need to add a few more elements on the real. Maybe it's something you want to rephrase afterwards. I'm just going to write it as I think about it. The rainfall intensity is correlated with the relationship. It's still bold, not bold. The relationship between rainfall intensity and debris flow triggering. No. The triggering of debris flow is controlled by rainfall and amount and intensity, as well as the topographic gradient and sediment availability. Which in turn, that's the assumption, availability. So the result, we have this and the rainfall change, and then influencing the necessary rainfall intensity to trigger debris flows are the sediment availability and the geometry of the gullies. Which both have changed over time, but which have changed in over time in both gullies. And then you show that, so you show that we have the planform change, and you need to explain the variability. You talk about the platform change in general, the channel gradient, and all of this. And once you have all of that, once you have the general elements, so we have, you see the variability by cross section, but we are talking about the whole gully which is changing. And you see when you have your channel gradient here, between 2002 and 2020, or your planform area, say that it's more widespread. Here you have areas that are very broad and areas that are not so much more narrow, when the overall trend is actually getting all much more similar, which is interesting. It shows that we had very broad planform, that's the planform change, sorry. So the planform change, some places were moving very fast, and slowly it's going down over time. So which is what you're saying here as well, so which is good. And then once you have that, you can talk about the cross section in particular. You zoom on each of them, and you have used beautiful graphics, which is perfect. And then once you have that, you say that the topography has changed. It means that the volume of sediment is different. So you have to change that graphic again, do a bit more of bits on this, and then it will work. Okay, so now in the introduction, let me go back quickly to what I was telling you when I met with you. You have to start with strato blah 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 volcanic erosion, volcanic. Maybe we can start with stratovolcanoes eruption generate. It's not the right. I'm going to put bullet points so that you know it's not a sentence. So start with eruptions on stratovolcanoes generate large amount of pyroclastic materials with sizes ranging from ash to a clay, basically. Clay, is it? No, from ash to large clasts, several meters in size. And then give some example here. Talk about Pinatubo, Merapi volcano, some volcano in South America, maybe you can Mount St. Helens. Give some example from the literature. So that's what creates the material. And then you have in the aftermath of eruptive periods, volcanoes are ridden by secondary erosion processes driven by gravity And water is not how you want to. That's when you talk about volcanic debris flows, and they are called lahar from the Indonesian terms. And then you give example of some work. I did a bit on Sema volcano, and I did some work also on Merapi with Unzen. Sakurajima. So give example of those elements. Maybe also Yakedake. Professor Su has written a lot. And those are the elements, okay. And maybe we can show that La occur in the years, in a few years after volcanic eruption occurred. And then over a long term, several thousand years, blah blah blah. You can talk. You can also say that should we talk about this? No. Then once you have said that, you can go to the paper by Tsunetaka and my paper in geoscience. And what you can say is that as when no new eruption occurs, the availability of sediments on the volcano is decreasing, less sediment available, and the slope that were the over-steepened slope the slope gradient decreases. And that's Tsunetaka's paper. And then we have this. Furthermore, changes in the watershed geometries modify the influx of water in the gullies, eventually limiting the number of debris flow. This reduction is further accentuated because fine material necessary for debris flows are being washed off by low energy, by low intensity rainfall, and are being washed off from the watershed, making the material more permeable. And that's what I say in my paper. And then when you talk about your own thing, however, the evolution of the gully profile and cross sections is arguably irregular, and the role of the gully geometry in the triggering of debris on the occurrence of debris flow is still fully understood, particularly when particularly as their frequency decreases with other. You will need to rephrase that. I'm just saying it is just the idea on how you can put your introduction. Decreases with other processes, relay processes. Becoming the gully as well. So let me put this would be for review, comment. This is about the flow of your introduction, but you will need to rewrite those and add all the fluff and papers that you have read. So when you have said that, then you can say that at Mount Unzen, blah, 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 and then you can introduce your study location. And that's it. I think that we should be fine then.